Hello friends, now in this series of normalization, till now we have solved two major problems. First, to identify candidate keys using functional dependencies, and then using those candidate keys to identify the normal form of a given table. Now before I switch to the next major problem where I'll discuss how to decompose a table into a desired normal form, I thought it would be better to have one more video. This contains some previous year GATE questions and some of the questions posted by a student on the YouTube channel. Again, we'll have some questions where first I identify the candidate key and then we identify the normal form, and in the next video I'll discuss how to decompose a table into a desired normal form. Okay friends, so now let's try to solve these questions. Now this question was asked in 1999 and they have already asked to identify the candidate keys, but we'll solve both. First we identify the candidate key and then using candidate key we'll identify the normal form. Okay, now let me check the dependency. First dependency again from C to F. Let me convert those dependencies into edges. So as we have already discussed, it will be convenient to solve if functional dependencies are represented in terms of edges. Okay, now first dependency is from C to F, then second I have from E to A, then we have from EC to D. Okay, from E and C what we can find D. Very good. And then from A we can find D. Okay, now let me rub those dependencies. Okay, now these are the dependencies. Now step number one, as we have done earlier, identify those attributes which do not have a incoming edge. You see, A have an incoming edge, B have an incoming edge, C it do not have an incoming edge. Okay, D and E also do not have an incoming edge. And then what about F? F have an incoming edge. Okay, now C and E do not have an incoming edge. Again, it means what? A candidate key is something which is able to find all the attributes, but you see here C and E are two attributes such that no other attributes can find them. It means what? Whatever the candidate key you have, this E and C must be the part of that candidate key, so I call them essential attribute. Now as we have done earlier, the first chance I'll give to what? EC. Now let's check whether EC or CE, they themselves are the candidate key. You see, from C we can find F, and from E only we can find what? A. From A we can find B, and then from C and E we can find what? D. Okay, so it was a very easy question. You see, from CE only we can find the entire relation. It means what? CE is a candidate key. And now you understand this thing. If CE itself is a candidate key which is essential attribute, now I'm sure that no other candidate key exists in the schema. Why? Because if I add something to this, it can become a super key. That is okay, but every candidate key will contain CE, and CE itself is a candidate key. So now that is for sure that there exists only one candidate key, what? CE. Again, let me tell you one thing how I have done that. Now from from C we can find what? F. From E I find A, from A I find B, and then from C and E both I find what? D. So all the attributes I can find. Now that was step number one. Now I'm sure there exists only one candidate key which is what? CE. Now step number two, I have to check all the dependencies whether they satisfy the rule of which normal form. So as we have done earlier, I'll always start from what? BC and F, and I have candidate key now what? CE. So again, let me check the first dependency, A to B. Now BCNF says what? This alpha should be a candidate key or a super key. Now you see, this A is not a candidate key, so this dependency is not allowed in what? BCNF. Then it is for sure the schema is not in what? BCNF. You see, it is not कि किसी एक dependency के लिए भी होगा तो चलेगा. No, the rule must satisfy every dependency. So if a relational schema is in BCNF, then whatever dependency we have from alpha to beta, every time for every dependency, this alpha must be a candidate key. And here I find a problem. There's a dependency from A to B, but this A is not a candidate key or a super key. Hence I conclude the schema cannot be in what? BCNF. Okay, now let me check now let me check the next normal form, which is what? Third normal form, or 3NF. In 3NF again we see, if there's a dependency from alpha to beta, then alpha either must be a candidate key or a super key, or beta can be a prime attribute. All these things we have already discussed. Now you see, alpha is not a candidate key or a super key, and for a surprise, beta is also not what, a prime attribute, because you see it do not belong to either C or E. So it means what, this schema is also not in what, third normal form. Now the third dependency we have to check in the coming form is what, second normal form. Now let me check whether the table is in second normal form or not. And as we have discussed earlier, second normal form do not allow what, partial dependency. So let me check whether there is some partial dependency or not. And you see there's a dependency here, C to F. Now you see C is a part of a candidate key. Now that is for sure that C is a prime attribute, but you see now this F is not a part of a candidate key. Now this non-prime attribute, instead of depending on the entire candidate key, it is depending only on what, the C. That is a clear-cut case of partial dependency. And now I can say if there exists at least one partial dependency in the table, it cannot be in what, second normal form. So the conclusion is this table is in what, first normal form. So we have solved the entire logic. First, using functional dependencies, we have identified the candidate key, and then using candidate key, we have identified the normal form. Okay, now let's try second question. This question was asked in Computer Science GATE 2005. Again, there was some functional dependencies, and the question was just to identify candidate key, but we'll solve it completely. Okay, again, as we do, first let me see, from A we can find what, B. Then from B, C we can find what, D. Then from E back we can find what, C. And from D we can find what, A. Okay, that is okay. Now again, step number one, what are the attributes which do not have an incoming edge? You see A, B, C and D all have an incoming edge, but E and H, they do not have an incoming edge. Now remember and note this point, some of you may feel it confusing. Now H is actually not participating in the functional dependency, neither an incoming nor an outgoing edge, even though if you are a candidate key, you must ensure that you can find every attribute. Now what you have to do, you have to take H from starting only, so H will also be a essential attribute. Okay, so now you see there are two essential attributes in this table, which is what, E and H. Okay, now let me check first thing, is E and H their self is a candidate key? You see from H is not participating at all. From E we can find what, C, but from C we further cannot find anything, because if I want to find D, then I have what, BC, and even if I have to find A, then I require what, D. So now in this case E, H is not themselves as a candidate key. Now what we have to do, if the essential attribute is not a candidate key, we must have one attribute every time, and let's give a fair chance to every attribute to become a candidate key with essential attribute EH. So let me take what, AEH, then let me take BEH, then CEH, and then what, DEH. And now let's check them one by one. Now what about AEH? You see from A we can find what, B, and from E we can find C, and from both B, C we can find D, and E already find H, and that is okay. It means what, this is for sure now a candidate key. Okay, now let's check about B, E and H. Okay, now from B, C we can find what, D, because E can find C, and then again from D we can find A, and H you already have. It means what, it is also a candidate key. Okay, let me check CEH. Okay, from D you can find what, from E you can find what, C, but again there is no advantage of having a C, because C itself cannot find D, so still it is not a candidate key. Okay, what about D, E and H? Now you see from D I can find what, A, and then from A I can find B, and I already have C because E can find C. Now I can find all the attributes. Now for a surprise, this D, E and H also becomes a candidate key. Now that is for sure that there are exactly 3 candidate key in the system. What are those? That is AEH, and then BEH, and then we have DEH. Okay, now to solve it further, let's understand the normal form. So as we have done in the previous question, let me start the discussion with what, BC and F. Now first dependency, A to B. Is A a candidate key? you see A is not a candidate key, hence the schema is not in BCNF. Okay, step number 2, we have A to BC. Is A a candidate key? Answer is no, A is not a candidate key, you see here. But is B a prime attribute? Yes, B is a prime attribute, B occurs here. So this dependency is allowed in 3 normal form. Now let me check BC to D. Again, you see BC is not a candidate key, but D is a prime attribute, that is okay. You check further. Now CE to C. Now you see, is E a candidate key? No, itself E is not a candidate key, but is C a prime attribute? Now C is also not a prime attribute. Now that is a clear-cut case of transitive dependency, hence the table is not in what? 3rd normal form. Now let me check the last normal form, 2nd normal form. Again, let me start from AB. Suppose, is A a part of a candidate key? Yes, it is. But B is a non-prime? No, B is a prime. Here we have already checked that D is a prime. Now let me check this, E to C. Now is E a part of a candidate key? Yes, certainly it is. It is a part of every candidate key. Now is C a non-prime attribute? Yes, still C is a non-prime attribute, because you see C do not occur in any of the candidate key. Now it's a clear-cut case again of partial dependency where non-prime attribute depends on the part of a candidate key instead of depending on the entire candidate key. Hence I conclude that this table is also not in what? 2nd normal forms, and this table is also in what? 1st normal form. Okay, now let's check out one more question. This question was asked in IT 2008. Okay, again there's a set of functional dependency, and let's solve it one by one. From AC we can find CD. Okay, from A and C, let me say we find CD, that is good. Then from DE we can find P. From DE we can find P. From C back we can find E. Okay, from C we can find what? E. From P we can find C. Okay, from P we can find what? C. And last, from B we can find what? G. Okay, from B we can find what? G. Again, question number 1, after studying functional dependency, what are the essential attributes? Let me rub this. What are the essential attributes? Okay, see, A is for sure essential, B is essential, because what are essential attributes? Which do not have any incoming edge. Okay, A is essential, B is essential, and then everybody else have an incoming edge. Okay, now again, step number 1, you should first check whether A, B themselves is a candidate key or not. You see, from A, B you can find what? C and D, and from C you can find what? E, and then again from D and E you can find P, and from B you can find G. That is a very easy case, you see, because here we find it out that A, B themselves is a candidate key, and these are essential attributes. Now if A, B is essential attribute and they are themselves a candidate key, now there's no need to check further, because now we are sure that there exists only one candidate key, which is what? A, B. Now let me go to step number 2 and let me check the normal form. Every time I start with what? B, C and F. Okay, now you see, first dependency AB. Now AB is a candidate key, that is okay. Now second you have DE. Now DE is not a candidate key or a super key, so it is not in B, C and F. Now let me check what? 3rd normal form. Again let me check, if AB is a candidate key, yes it is, go to second. DE is a candidate key, no it is not. Is P a prime attribute? Now certainly P is a prime, certainly P is not a prime attribute, hence it is also not in 3rd normal form. Now let me check 2nd normal form. Now for 2nd normal form you can try, for some partial you can try this BG. Now you see, G is not a part of a candidate key, so G is a non-prime attribute, but B is a part of a candidate key. Now here you have a non-prime attribute, and instead of depending on the entire candidate key, it is depending only on what? B. Now that's a clear-cut case of partial dependency. Again this time also the conclusion is same. Again this table is in what? 1st normal form. Acha, make a note of this. You must be feeling amazed that why it is happening most of the time that we ended up on what, first normal form. You see, these questions are actually not designed to find normal form. These are most of the time asked only to find the candidate key, but we are solving them to find normal form. And actually it is not very easy even to go for second or third normal form, even in industry also. So most of the time if you don't do any homework before on the schema and on functional dependency, then you will end up on first normal form. But I'm going logic by logic again, because in GATE or not or any competitive exam, you see, you must go in order. First you check BCNF, then 3NF, and then what, 2NF. Okay, now let's try one more question. Now that was a question in the previous video I have given in the assignment. Actually it was a 4-mark link question asked in GATE 2013. Yes, 4-mark link question. First 2 mark was to identify the candidate key, and the second 2 mark was to identify the normal form. Now let's try this question. Okay, now you see there's a number of functional dependency. First let me study them. From C and H we can find what, G, that is okay. Then from A I can find BC, that is also okay. From A we find BC. Then from B we find C, F and H. From B we find what, we find C, we find F, and then we find H. Okay, from E we find back A. From E we find A, and then from F we find E and G. Okay, from F we find E, and then we find G. Again, step number 1, what are the attributes we don't have an incoming edge? You see, A, B, C, first you find out D. Now D do not have an incoming edge, and apart from that everybody else have an incoming edge. And again, for a surprise, you see, now D is not participating in what, functional dependency at all. Now what I have to do, I have to check now for every possible combination to find whether they are key or not. That is okay. It was again a 4-mark question, so it deserved that much effort. Okay, let me try one by one every possibility. AD I have, BD I have, CD, and then DE, and then DF, and then DG, and then what, DH. Okay, now let's try. First, AD. Is AD a candidate key? You see, from A we can find what, BC. Okay, from B alone we can find C, and then F, and then H. Okay, and then from F we can find E and G. And I think that was all, everything we have found it out. It means what, A is a candidate key. That is good. Now second we try BD. Okay, again from B we can find C, F and H, and from F we can find E and G, and from E we can back find what, A. That again everything is already find it out. Then it means what, BD is also a candidate key. Okay, now let's try CD. Okay, now you see, from C alone what we can find? You see, from C alone we cannot find anything, because C and H they together, combinedly together find G, but C akela kuch nahi kar pa raha hai. So again we can say this CD itself is not a candidate key. Okay, and now let's try DE. Now you see, from E I can find A, from A I find BC, and again from B I can find C, F and H, and I find everything. It means what, DE is also a candidate key. Now what about DF? You see, from F I can find again E and G, and then from E I find A, and A I find BC, and B I find everything. It means what, is also a candidate key. Okay, now what about DG? You see, from D and G, now G itself do not find anything, because G, it has an incoming edge, not outgoing edge, so it is not a key. And then let me find in the last H. You see, at H alone cannot find anything, because H and C together they find G, so it is also not a candidate key. It means what, already we have found how many candidate keys? 4 candidate keys. But you see, I should not end this process mathematically. I should also check what, how many fails here. You see, CD fails here, then DG fails here, and then DH fail here. I should also have tried, and I will try the combinations of them. That is what, from D let me came together with suppose karo D and G. Then again from D let me have what, G and H, and from D let me check C and H. So I have now considered the pair of 3, and these all are failures. Now let me try them together. Now C and G, You see why I'm not trying any other combination with those keys, because they are already proved to be candidate key, so I cannot make them a subset of any other key, but these are failures, so I can try this combination. Now what about D, C and G? You see from C alone we cannot find anything, and still from G you cannot find anything, so again it is also not a key. Now what about G and H? Now again H itself cannot find G, and G don't find anything, it is also not a key. Now what about C and H? You see C and H, okay, they together can find G, but still like something called E and A and B, we cannot find that, so it is not also a candidate key. Now I have checked all the three combinations. Now I'll check also one more combination, the last combination, and let me merge them together. Now with D, let me find C, G and H. Now let's see what together they can do. From C and H we can find what? G, but still I cannot find A, B, or I cannot find something like E, so it means what? Still it is not a candidate key. So answer to the question is there are only 4 candidate key here: A, D, B, D, D, E and what? C, F. Okay, now let's go to question number 2 and let's try to identify the normal form of it. Okay, now first again I'll check for BCNF, and then I'll check for 3NF, and then again I'll check for what? 2NF, and if not possible then automatically becomes what? First NF. Okay, let me check. CH. Is CH a candidate key? No, CH is not a candidate key. The table cannot be in BCNF. That is okay. Now again let me check for 3NF. Now is G a prime attribute? CF, it's not a candidate key. Is G a prime attribute? Now you see G is not a prime attribute. That is a clear-cut case of transitive dependency. It means what? It is also not in what? Third normal form. Now let me check for 2 normal form. Is CH a part of a candidate key? No. Let's proceed further. Is A a part of a candidate key? Yes. Is B a prime attribute? Yes. Is C a prime attribute? You see C is not a prime attribute, so now that is a functional dependency. I can decompose it in 2 parts, A to B and A to C. You see now there is a culprit, A to C. Now A is a part of a candidate key, so A is a prime attribute, and C is not part of any candidate key, so C is a non-prime attribute. And when a non-prime attribute, instead of depending on the entire candidate key, it depends on the part of a candidate key. It's a clear-cut case of partial dependency, and if there's a partial dependency, the table cannot be in what? Second normal form. Hence again I conclude that it is also in what? First normal form. Okay, now let's try one more question. You see this question number 5, it's not a previous year question. This is this question was posted by a student Riddhi, so now on the YouTube video. So now let's try this question. Okay, now in this case you have very simple dependencies. From A I can find what? B, and then from B I can find what? C, and then back from C I can find what? B and D. Okay, now again let's try step number 1. What are the attributes who don't have an incoming edge? You see clear cut A is an essential attribute because A do not have any incoming edge. Okay, now let's understand, if A do not have any incoming edge, is A itself a candidate key? Now let's see, from A I can find B, from B I can find C, and from C back I can find what? D. Yes, A itself a candidate key. Now there exists only one candidate key because essential attribute itself becomes what? A candidate key. Now no need to check further. Now let me check first. A to BC, is A candidate key? Yes, it is. Now B is not a candidate key. If B is not a candidate key, now the schema cannot be in what? First normal BCNF. Then now let me check for what? Third normal form. Again you see A is a candidate key, that is okay. Then next you have what? B to C. Now B is not a candidate key, and C is also not a prime attribute, hence it is also not in third normal form. Now let me check what? The second normal form. Now let me check for what? Partial dependency. But now you understand, this table is always in second normal form. Why? Because the size of a candidate key is 1, and when the size of a candidate key is 1, you can never have a case of a partial dependency, so there is no need to check, and hence I conclude that the table is in what? Second normal form. Now remember this point, As I told you now, just in this videos I have, I am concentrating on the basic logic, so there are very little tricks. For example, if somebody say the table contains only 2 attributes, find the normal form. You see, it is always is in BCNF. Why? Because in 2 set of, or if you have only 2 attributes, how can you have a partial dependency? Similarly, when the size of a candidate key is 1, you can never have what? A partial dependency. So this table is already in what? Second normal form. Okay, now let's check out the last question. This question was also posted by student Sandeep. He mailed me the question. Now let's solve this question. So there are a number of candidate keys, and we have to identify the first there are a number of functional dependencies. First we have to identify the candidate keys, and then based on candidate keys, normal forms. Okay, now you see, from AB I can find what? CD, that is okay. There are a number of dependencies. From C and D I can find E and F. Okay, then from B, C I find D, E and F. Okay, from B and C again I find D, E and F. Again, then from D I find B, from D I find B, and then from CF I find CE. From CF from CE I find F. Okay, then from C and E I find what? F. Okay, again step number 1, what are the essential attributes? You see, B also have an incoming edge, but A do not have an incoming edge, so A becomes essential. Is A itself a candidate key? Answer is clear cut no here, because you see A itself cannot find anything. Now let me check every possible combination. Then AB, then AC, then AD, then AE, and then what? AF. Okay, now is AB a candidate key? You see, from AB you find CD, from CD you find EF. For sure A is a candidate key. Now is AC a candidate key? You see, from C alone I cannot find anything, because it required 2 dependency, and CD also required 2 dependency. So for sure AC is not a candidate key. Now what about AD? You see, from D only I can find what? B. And if you have AB you can find CD, from CD you can find EF. For sure AD is also candidate key. Now what about AE? You see, again from E alone I cannot find anything, because E requires what? C together. So again AE is not a candidate key. And the last one, AF, you see, from F it do not have any outgoing edge, so it can never be a candidate key. So there are only right now we have already find 2 candidate keys, AD and AB and AD. Now what should I do? I should check every possible combinations of the failure, like we have did in the previous question. So let me check AC and E. A is essential. Let me check AE and F, and let me check what? AC and F. Okay, let's check AC and E. Okay, C and E can together do what? You see, C and E can together this time can find what? F. Okay, but can they find D? I think no, because you have only what? AC. Now from C and E you find F, but still there exists no method to find B, I think, because yes, you cannot find what? D, or you cannot find B, so still it is not a candidate key, even though it is finding F. Okay, again from E and F, you see E and F, again E has a 1 outgoing edge, but still it is finding what? F. You cannot find anything. Then you find what? C and F. Okay, from C and F still you cannot find anything, so again it is not a candidate key. Now last attempt, let me check let me combine all possible failures, A, C, E and F. Okay, C, E and F. Now you see, from C and E you can find F, but still there are 2 problems we have. A and D and BC you cannot find them, so it means what? For final there exists only 2 candidate key, one is AB and one is what? AD. Now step number 2, let's me check for what? Normal form. Now again as usual I'll start with what? BC and F, then to third normal form, then to second normal form, and then automatically we'll go for first normal form. Now BC and F. Now AD is a candidate key, that is okay. Now CD. Now CD is a candidate key. Answer is no, CD is not a candidate key. So it cannot be in BC and F. Then loud, let me check what? For third normal form. AD is already being checked, CD is not a candidate key, but E and F, are they prime attribute? No, E and F are no prime attributes, so it is also not in what? Third normal form. Now let me check the last one, second normal form. Now you see, let me find AB. There is some dependency from A to B. A to B, that's a total dependency in here, A and B or D. Now that is the case, but that is also a total dependency. Okay, now here if you see, second normal form is an interesting case here, because from AD you can find CD, that is okay. I have to find partial dependency, so I have to find some of the part of a key. Now it is itself a key. Now C and D together, you see D is a part of a key, but C is not a part of a key, so I cannot treat it as partial, because partial required to be a subset of a key, and it is not a subset of a key, so I cannot treat it. Now BC, now again B is a part but C is not a part, so I cannot treat it. Now D to B, now D is a part of a key, but for B is also a part of a key, so now it is also not a partial dependency. And C to E, both of them is not a part of a candidate key. So I think this table will be in what? Second normal form, because there exists no clear-cut case of what? Partial dependency. Okay, so I hope now the topic will be cleared to all of you, because we have solved a number of questions. Okay, now in the next video I'll discuss how to decompose a table into a desired normal form, and then we'll continue with transactions and concurrency control, as most of the students have posted in the comments that they find or they want the videos of transaction concurrency. Okay, thank you.